Welcome back to the second part of this video. In this example, we've got a pin jointed truss which has got two concentrated loads at points B and C, each of magnitude F. We've got two supports, one support which is a pin support at point D and one is a roller support at point A. Work out the reaction forces at point A and D. And likewise, I've also attached the same key on the right hand side. So with the roller support, we're going to have one force, which is the vertical reaction force, whereas the pin support, we're going to have two reaction forces. We're going to have a vertical and a horizontal. So let's start out by making a free body diagram. So how is this going to look? Well, what we want to do is just get the general shape of this truss. So that's this sort of shape. We've got a vertical force at point A, which is the reaction force from the roller support. As that's at point A, we're just going to label that VA. We've got two reaction forces at point D. We know that we've got a horizontal force, and from my key I usually keep it to the right. So let's just say we've got a horizontal force HD going to the right, which is positive. We also have one vertical force going straight up from point D, and then we can add that reaction force in, which is VD. Now we know we've got a reaction force, we've got two concentrated forces F at points B and C. So let's just draw the general shape, which is points C, which is going to be F, and at point B we're going to have another F. So using our three equations as we've discussed in the previous videos, which is going to be the sum of the forces going vertically up must equal 0, as this is stable and not moving. We've got the forces going to the right should also equal 0, and the sum of the moments should also equal 0. So using these three equations, we should be able to identify the reaction forces at A and D. So let's start out by looking at the forces going up. So the sum of the forces going up as positive should equal 0. In this example, we've got a vertical force of VA and a vertical force of VD going both in the upward direction. So we can say that's VA plus VD, but let's not forget the force F at point C going down. As it's going down, so it's a negative, minus F is equal to 0. And the rest, which is F at point B and HD going to the right. So we can't include that. And as we've got two unknowns with only one equation, we can't really do much with this. So we need to carry on with another equation. So we can say the sum of the forces going to the right is equal to 0. And like I mentioned before, we've got two. We've got F and HD, and they're both going to the right, so they'll both be positive. So F plus HD is equal to 0. And from this, we've got one unknown in this equation, therefore we can find HD, and that's just going to be rearranging to make HD the subject, which is HD is therefore equal to minus F. So that's one of your reaction forces. So we know that this HD is minus F, and what this minus means is what we assumed this reaction going to the right is actually going to the left. So that's all that means. So now we can use the last equation, which is the summation of moments, and that should all equal to 0, again clockwise going positive. Now, as usual, we want to use probably the point where we've got the most forces, as they'll cancel through, using as the perpendicular distance will be 0. So we know that point D has got the most forces, and also an unknown, so we can cancel that through. So it would make sense to do the summation of moments at point D. Likewise, we could do it anywhere else, but it would be a lot easier to do at point D. So, as therefore these 2 points cancelled out, we've only got 3 forces in play. VA, F at point B, and F at point C. So, using this diagram, the moments, we know it's going to be force times perpendicular distance. So the perpendicular distance from point A to point D is going to be this value here, which is x plus whatever this distance here is to this point going down. So we know this distance x plus x, which is 2x. So now we need to find out this distance here between point E and D. And what we notice is that this is actually just half a triangle, and also we could use trigonometry by using these values as x as the base and height as also x. But what we find out is that distance here is x over 2, just half a triangle. So we know the perpendicular distance from A to D is 2x plus another half x. So that distance is 2x plus x over 2, which is 2.5x, also written as 5 over 2x. So, as VA is going up and to the right, we know that's going to be a clockwise force. So that's VA going up, to the right, and back around, which again is a clockwise moment. So that's VA multiplied by 5 over 2x. So now we need to look at the 2 other forces in play, which is F at point B and F at point C. While looking at F at point B, that lies on the same plane as the reaction point of D. So therefore the perpendicular distance between B and D is actually 0. There is no perpendicular distance. So that goes to 0. So now we just have to look at force F at point C, which is a force going down, to the right, and back up, and that moment is counterclockwise, so that's going to be a negative. And we can see that the perpendicular distance between point C and D is the length of, or the base of this triangle, which is just x. So therefore the moment is going to be the force times the distance, which is just fx, is equal to 0. And therefore we can say that VA 5 over 2 is equal to F, as we can just cancel the x throughs on both sides as they're a common factor. Therefore, rearranging just to get VA on its own is 2F over 5. So that's our VA. So what we can do now is substitute VA back into this equation. We will label equation 1 to get VD. So we can say sub VA is equal to 2/5 of F into equation 1. Therefore, we get 2/5 F plus VD minus F is equal to 0. And therefore, we can say VD is equal to positive F, adding on the other side, minus 2 over 5 F VD is equal to 3/5 F. And that's our final reaction. So we've got VD, VA, and HD. So I hope that helps, and if you have any other questions, or if you did not quite understand that, please feel free to leave it in the comments down below. Please do like and subscribe this video, and if there's any other videos you would like to see, again, please list it in the comments below, and I'm sure to read it and help you guys.